Okay, I guess we'll get started. Good afternoon. My name is Charles Morris. I'm Director of Marketing here at AGFA Healthcare. And today we're going to talk a little bit about web streaming technology and how web streaming is actually helping enable cloud utilization for medical imaging. And hopefully what we'll do today is we'll talk a little bit about our technology and some of the challenges that we run across and some of the claims that I'll say some of the organizations that we work with have that we think are misconceptions. The first one is that images served directly from the cloud can be slow, and I don't disagree with legacy technology. Sometimes that can be slow. There's also egress in cloud. I think everybody's probably aware of that, and that egress can be prohibitive. And I will kind of go through this today, and we'll talk about how AGFA is dealing with this, among other issues. And what I hear on a frequent basis is when we're talking about our customers adopting cloud, a lot of times they say, but we're not close to an AWS data center, and therefore it's probably not good for us. And we'll directly address that by how we're enabling cloud and eliminating these kind of specific challenges. So I think hopefully everybody is aware that DICOM's the backbone of the medical imaging industry. You may or may not know that it was actually invented in 1985. And we had a very different world in 1985 as far as networks and data than we do today. In 86, that's when the first internet, I'm using air quotes, was actually created. And part of our problem in those days was that our networks were noisy. They weren't fiber digital networks really sending good high quality data. And so built into the DICOM transmission protocol is a concept called an acknowledgement. And it simply says, I send you some data, you acknowledge to me, I stop sending data, then you acknowledge to me that you received the data, then I can start sending the next packet of data. And those acknowledgement packets have to be sent back and forth between the client and the server. And so if you're sending something like a single image, it's not a big deal. But if you're sending something like 1,000 slice CT, there can be 2,000 of those acknowledgements going back and forth that aren't sending any data. That dramatically reduces the actual usable pipeline of your network. And it's one of the core challenges that we have in medical imaging is this legacy protocol. Now, so data sets are downloaded, ACKs are used, and because of those ACKs, it's really sensitive to latency. Latency, I think everybody knows the term, but what it really means is it just how far am I from my server time-wise, right? And so all traditional legacy imaging systems are very sensitive to latency. And effectively, kind of what was happening in the early days of cloud is that we had legacy DICOM applications trying to use the cloud. We had these acknowledgement messages which are consuming bandwidth, which produced high latency, and ultimately it made dissatisfied users. And so there was this early perception that cloud wasn't really mated well for imaging. Well, hopefully today you'll learn that that's changed dramatically. Now, I'm going to go through a very quick history, very rapidly, of generational imaging systems because we have progressed pretty dramatically in this industry. The first generation of systems used raw DICOM, and it was downloaded to a client, and there was a GPU living inside that workstation. We had to have very high-end, high-powered GPUs in order to process these images. Second generation came around, and then they started moving into a proprietary download form, which shortened the download time, but we still had to wait for the image to get to the workstation, and I still had to have a GPU and a high-power workstation, and then I did all my work locally under my desk, right? Third generation, as an industry, some companies started coming around to the idea of using web and started to use non-proprietary formats like JPEG, which further expedited the download of the data. We're still in a download data world. And, but we still had GPUs living in these kind of high horsepower workstations. Now, Gen 4 This has really only been popularized in the last couple years, just to give you a timeline between 1998 and today. They started doing server-side rendering and streaming the primary images to the client. So no longer are we downloading the data, we're remotely viewing the data effectively. It's kind of how all of us use something like Netflix. When you poke the button, you get to see the data, but you don't download the MPEG file and view it on your local thing, right? Now, the challenge is with that generation of technology is it still requires that GPU server side. And if you have a sizable operation, it gets very expensive. I don't know if you guys have heard of this other stuff called AI that uses GPUs, and there's the worldwide consumption of GPUs, so they're kind of hard to get hold of. And but now we're starting to move into a world where now our workstations are quite a bit smaller, right? We don't have to have that big workstation under our desk. And I give credit to the Gen 4 group because they got it to work, right? They really started to get it to work. But they live in this world between lossy and lossless compression. And if you're a physician, you don't want to ever question whether the image that you're looking at is full fidelity or not, right? It has to be full fidelity. You have to have 100% confidence before you make your determination and you move on and recommend treatment, right? Now, Gen 5, which is what AGFA, we believe that we've invented, this is a first on the market, is we finally got to a point where we have a pure HTML5 viewer that not only does not require GPUs on the client, it doesn't require GPUs in the cloud either, right? Or on the server. Pure HTML5 client and is always lossless. I'll talk a little bit about some of the unique strategies that are in here that deal with latency in a second. But it really is Gen 5, and we've been running this for a little while now, and I'll show you some of the statistics of the overall benefits. Now, I often get asked, well, how does this work? Well, effectively, we've partnered with AWS. We have our SaaS for enterprise imaging platform running with AWS, and I'll go into what the stack and the services look like in a second. But effectively now, what our customers need is basically any PC, calibrated monitor, and an internet connection. That's really all they need now, right? And it works just as well on a mobile device. But I think the big points here are that it's latency and bandwidth tolerant. In particular, when COVID came around, a lot of our radiologists started trying to work at home and not at the office. And now they like working at home. They don't want to work at the office. And so we're, creating technologies that enable them to do what they do more conveniently. And getting back to the original points of this presentation is that this type of technology is egress efficient because we have this thing called pixel memory. And there's two different types of streaming. I'll talk about them in a second. But this particular type is very well made for cloud. If you have your own data center and you don't care about egress, then the other one's probably okay. But if you're going to use cloud, this is really the way that you want to go. Now, in our technology, I don't know how many people in the audience here are network nerds like I am, but this technology that we're building really is ideal for more or less what the US government considers broadband. And the goal of the US government is to have the entire country saturated in what they define as broadband. And that's kind of our floor of what we're trying to look at. So anything over 20 megabit, if you these days are sitting on 20 megabit, like you're in a farm somewhere, like anybody in the city is 10 times this, 20 times this in the city. And latency for milliseconds, I'll show you a map here in a second, what 60 milliseconds means on a network. But ultimately this specification as a condition of use of this type of viewing technology is what overcomes those deficiencies that we started with, right? Now, AWS has a data center in Ohio. It's one of the data centers that we use for our service. And 60 milliseconds in unimpeded fiber means that you can run a service for imaging out of the Ohio data center, and you can be a client anywhere in the continental United States from a single data center. Now, wherever your organization is, we're not going to recommend you go to Ohio. If you're in California, we'll put you in the California data center, or whichever one's most convenient. But if you have consulting radiologists, consulting physicians, consulting oncologists, whatever, anywhere in the country, they can get full fidelity, full speed access to this image data wherever they're sitting. We don't have to wait for data to move to users anymore. We take the user to the data, which is exactly what we do with Netflix, right? The way it works is I poke the button to watch the video, and it makes a split-second decision of which server is available, which one has the film or movie I want to watch, and then it routes me to that node. When I hit the next episode of my show, it makes the same decision again, and it may send me to a different place. So this is using very, very modern network technology. It's very web-like. And something else that we accomplished during this is that most organizations have to make two decisions in their enterprise. What do we use as a diagnostic viewing application? And then what do we use as an EHR web clinical access application? And usually they're different. Because of how this technology functions, we've converged those really into a single client. So no longer do organizations have to deploy two decisions for diagnostic and clinical access. So talking about those statistics I was talking about before, this is a test that our product management team did with a very well-known Gen 4 viewer. We don't make a Gen 4 viewer, just to be clear. And they ran basically the same 800 slice CT. And here's the use case. I want to be very clear about how this was generated. Is that you open the study, you get through the first scroll like of the image, and then you work with the study, okay? And it was about a 5-minute session or something like this. The Gen 4 streaming technology, as you're working with that image, it's persistently, consistently running at 3.5 megabytes per second on the network. It's about 30 megabit, right? But if you have hundreds of users, that stacks up really, really quickly, and your network will very quickly become saturated. So it's a great technology. I don't have to wait for downloads, but I have this server-side, GPU problem, and then I have this network capacity problem ultimately. This Gen 5 tech, it drops that all the way down to about 32 kilobits per second, which is almost a rounding error in modern networks. It's a whole magnitude, basically, lower network use. And as you can see, you would think it would correlate, right, to the actual data download is also a whole magnitude less, meaning our egress costs drop off by a whole magnitude. So it's significant in how that works. And again, these are, I think they're important, but in the Gen 4 stuff, we're having to bounce back and forth between lossy and lossless. And as you see viewers, if they're using this, just witness what happens. They'll be manipulating an image, moving it around the screen. It's lossy, then they'll let go of the mouse, and then they'll count 1, 1,000, 2, 1,000, and it'll snap into a lossless mode. And as a user, you have to wait for that constant snapping to happen. This thing does this always lossless. And sometimes they use an installed client, sometimes they can do it over web, but again, this tech is all HTML5. And I'll let you know that I don't know if anybody here has heard of Class. I think everybody's pretty much heard of Class, but this specific viewer was the best in class for this year. So it really has come along. Now, if you're a regional organization or have a large network of affiliates, advisors, consulting physicians, we highly recommend that if you're going to build a viewing network, our technology is capable of building multi-entity, collaborative, affiliated networks of viewing, where you view the data from the source, you don't import the data. And we highly recommend that you use AWS's backbone for this particular task. They have absolutely the best backbone network of any provider in the market. It's one of the reasons we partnered with them. Not the only one, mind you. They're great, but their network is fantastic. We actually have, I'll encourage anybody that's here to our booth's right next door, it's right there. I encourage anybody that wants to see this in action. We have a demo that we have a render node in California, we have a render node in Ohio, we have a render node in Korea, and you can see the speed of data moving from Korea to here. It's the reason they picked Korea. It's the longest network link that's available on the network, and you can actually see it. It's pretty darn impressive. Now, this is a cloud native application for all of your infrastructure nerds like myself in the audience. And it uses a full stack of AWS services, right? This is not a lift and shift application. It's something that's very finely tuned. We built this in conjunction with AWS in order to really get the best use out of their infrastructure. Now, people want to know why is this thing intelligent, right? And because I use that term all the time, intelligent streaming. There's two ways we can slice this. Is anybody familiar with like how Citrix works? Citrix like paints the whole screen every single second, like keeps painting it, and that sends a lot of data. That's one of the reasons why the Gen 4 is not really smart. Ours is intelligent and awesome because it's actually sensitive to the areas on the screen that are changing. And it's only sending data that's physically changing. If I'm not changing the viewports on the bottom, it's not sending the data. That's one of the ways that we get this transmission volume down and the speed up, right? And so that's really great. And then second, people ask me, well, what about Mammo and these gigantic multi-gigabyte DBT files? Absolutely, it does it. And it's actually really simple how we do this. The client never sees the DBT file. It's always on the server. The only thing we ever send to the client are the pixels that are physically on the screen. So the performance of a DBT study versus a plain chest film is the same. It takes a little while to kind of think about that, but I'm sending the same amount of pixels to fill a diagnostic monitor, whether it's a DBT or a chest film. So it's super fast, in particular on the largest studies. People ask, what about multidisciplinary imaging? And because it is also our universal viewer, our enterprise viewer, it supports all major disciplines: cardiology, radiology, ECG, point of care ultrasound, clinical photography, video, audio. It does all that as well. And how about actually accessing it from anywhere? So this is one of our developers' cars. I can't mention the brand name, right? But I think everybody gets the idea. And when we say it's a lightweight HTML5 viewer, it can be embedded literally in anything that can support HTML5, including that. So it was, my legal team basically said you should probably put, please do not read studies on autopilot, while you're going to work. Don't do that. We don't recommend that, by the way. Just that's our legal position. So our service that has this viewing system is available as a full SaaS on AWS as a managed service. And there's a number of reasons why we recommend organizations take a look at SaaS. Is it for everybody? No, but it does really meet the needs of certain types of organizations that really want to get back to the business of healthcare as opposed to being IT companies, right? In the same way that we want our customers to look at us as a provider and knowledge provider of this type of class of system, we depend on AWS to be our infrastructure providers. We don't want to be in the infrastructure business either, right? So we're their partner, you're our partner, all right? It's the way that it kind of works out well. Now, probably the biggest thing for cloud that most of our customers want is time to value. They're tired of projects that take 2 years, 3 years, or these extended times to actually bring it to their organization and make it work. So, of course, it has amazing uptime, and the security that AWS provides behind this data is top in the industry. There really is no better security firm than AWS with the data. They have more on the line than the rest of us. So, excellent. Well, thank you so much for your time.